Hi everybody, take 2 with tonight's video because I already did this once and then I forgot to save it and I deleted it. So I'll do it again for you so that we can be prepared for tomorrow's lab where we will actually experimentally determine the molar mass of a gas. That's what we're going to do tomorrow. Okay? So in order to see how molar mass is related to all this gas stuff, I want to derive the relationship for you. I know it sounds like calculus now, right? I want to derive the relationship for you. So if you remember, molar mass is formula mass. And what you need in order to find formula mass are grams and moles. It's grams over moles, right? So it's mass over N, because N is your moles. If we rearrange this and solve for moles, okay, so we would have to slap this over 1 and we get molar mass times moles equals grams. And then solve for moles by dividing both sides by molar mass. Then what you notice is that the moles, or the N, equals the grams, or the mass, over the molar mass. Okay, now let's relate this to the ideal gas law. Pivner, PV equals nRT, we can substitute for N, we can substitute this grams over molar mass in here. So PV equals grams times R times T over molar mass, right? If we substitute that in for N. And now rearrange this to solve for pressure and then eventually molar mass. So I want molar mass by itself. So I'm going to slap this over 1 and cross multiply. So you'll get grams times R times T equals P times V times molar mass. Molar mass. And now let's get molar mass by itself by dividing this side by PV and dividing this side by PV. Okay? So what molar mass is really equal to then is your mass, or your grams, times your R times your T divided by your volume times your pressure. Okay? So if we know the volume that a gas occupies in liters, the pressure that a gas exerts in atmospheres, the temperature of the gas in Kelvin, and the mass of the gas, we can actually calculate the molar mass of the gas. And then I know what the real gas is. We can have the actual molar mass and get a percent error. So that's what we'll be doing in tomorrow's lab. We will collect a gas underwater, or over water, if you will, and we'll be able to calculate the molar mass of that gas and compare it to the actual. We can shorten this even more because grams, mass over volume, is a thing that you know. Do y'all know what mass over volume is? It is! It's density. It's density. Good, Jess. So it's dRT over P. So you could simplify that even more. Molar mass, I call this equation dirty P. Molar mass of a gas is equal to dRT over P. Density then would be in the units of grams per liter in this equation, so that it would jive with the other constants here. Okay? So I'll walk you through. This equation relates the density of a gas to its molar mass. If you know the density, you can get the molar mass of a gas. I'll walk you through a practice problem with that next. So the density of a gas was measured at 1 atmosphere. 1.5 atmospheres and 27 degrees Celsius, which is 300 Kelvin, and found to be 1.95 grams per liter. Calculate the molar mass of the gas. So this equation that relates molar mass to density is not given to you in your AP tables. It's one I would recommend you commit to memory so that you don't have to go through that very long derivation that I just showed you on the last page. So just remember, molar mass is dirty P. Dirty P, right? dRT over P. So we have our density, 1.95 grams per liter. We have our R, 0.0820, I'm going to do 1 liter atmospheres per kmol. And we have our temperature, which is 300 Kelvin. Okay? And we're going to divide that by our pressure, which is 1.5 atmospheres. So if you just look at the units here, you should recognize that the liters cancel out, the atmospheres cancel out, and the kelvins cancel out. So the units that are left are grams in the numerator and moles in the denominator, which is what you need to calculate molar mass. God bless you. And so if you multiply by all the tops and divide by the bottoms, I think you get your molar mass of your gas to be 32. So if it's an unknown gas, automatically I know I can eliminate, oh, my gas isn't hydrogen because it doesn't have this molar mass, right? My gas might be oxygen because oxygen's molar mass, O2, is 32. So you can use the equation to calculate the molar mass of your gas. Okay? And experimentally, we'll be doing that tomorrow. I would like you to do the 2 problems in homework number 3 that we did not have to do last night, which are questions from chapter 5, number 61 and number 63. They relate to the dirty P equation. Molar mass is dirty P. Okay? Have a great night, everybody. We'll see you bright and early tomorrow morning. Bye-bye.